Thanks everyone for joining. Today is going to be a quick session on architecture best practices on Amazon AWS. So my name is Julien Lepine. I'm a solutions architect working for AWS for anything that is Microsoft related across EMEA. So you may have to come with, you may see me either in your company or with your customers if you need any help from AWS. I'm just here to help you. So today we're going to talk about architecture. Not that much about products and development, but we'll try to get some time for a demo at the end. So why does architecture matter? When you start deploying and developing a new applications, you want your application first to be usable and to have a use for your customers. For that, we cannot be of any help. It's your choice, it's your application, and you want to be able to help your customers. But when it comes to hosting your applications, you want to have applications that are secure. That's going to be your #1 priority. You also want applications that are performant. You want your user to be able to access the application wherever they are in a really just, a few milliseconds kind of way of accessing the application. You also want your application to be fault tolerant. So in the event of a failure of a machine, of a hard drive, of a database, of an OS patch or something, your machine is going to fail. That's just the way it is. So you want to architect your application around it to make sure that even if a failure was to happen, your application will still be up and running and your users will be able to use it. And last but not the least, you want your application to be as cost efficient as possible. You don't want to pay a lot just to have an application running. You want to pay a lot if you have a lot of users, because if you have a lot of users, you're making lots of money, hopefully. And then you can pay a lot. But if you don't have many users, you don't want to pay a lot because you're not making that much money. So you want to have an application that scales as needed on the basis of how it's used. So to start up, step 0, you want to plan for security. That's something you cannot avoid. You should start every single project by planning for security. Who's going to access my application, from where, and make sure that you have the good principles embedded in your code directly. So AWS can help you with that. We have multiple services. We have more than 40 services now available on the platform that give you access to many levels of security. Quickly, 3 important points in security. You want to have network security, making sure that only the people that are supposed to access your application can. And the first way to do that is to manage the network, making sure that you have the IP addresses that you want that are managed. If it's internet, that's pretty easy. But if it's an internal application for one of your customers, you may want to have a VPN or some sort of things to make sure that only the people that are supposed to access the application can do that. Then you want to manage access to the platform. You don't want your information to be available on the internet. You want the information, your information and the information of your customers to be highly secure, to make sure that you have a full auditability of everything that's going on. And we have a service that's called AWS Identity and Access Management that's made just for that. You specify who can access what data, from where, at what time of the day, so you have really a fine-grained security principles available. Last, you can also decide to cipher your data. So you can choose between different encryption methods, either provided by AWS, free of charge. So it's just a click of a button to have something that will be encrypted end-to-end. Or you may even want to have full control over the security keys, so making sure that you have hardware security modules on premises and you manage the encryption from end-to-end. So depending on the level of security you want to have, you can pretty much implement everything on AWS. So for this talk, we're going to start simple with an application. And that's the typical dev setup. And don't tell me you've never seen an application such as this one. It's basically a single machine. Someone just dev'd an application, just put up a SQL server, a standard or even an Express one on the machine, has some ASP.NET deployed on IIS, and it just runs. So that's fine. It runs. And it's something we see in many companies. And by the way, it just works. So that's one of the good things of this setup. It's really simple to implement. But after some time, you may hit some limits. Because the application usually, when it works, many people start using it. Either it's internal users or even web users. But even with just internal users, you're going to have some tens or hundreds of users of your application. And you'll hit some walls. So CPU limits, RAM limits, storage, network, so all the limits you can have. So how to get out of that? The first idea is an idea from what we call the old world, which is just vertical scaling. Get a bigger box. So you get the same application, you just put a bigger box, And on AWS, we have more than 35 different instance types, so you can have machines with 36 vCPUs, hundreds of gigs of RAM, or even terabytes of SSD drives. So you can have really big machines for your big workloads. But it's going to come to an end. After some time, you will hit the wall of, I got the bigger box there is on the market, and either I'm going to start paying a lot to get really, really heavy boxes, or I think differently. And if we get back to the development principles, one of them, if you take solid applications, the first one is single responsibility. So single responsibility lies in the fact that if you have multiple aspects in your application, you want to have them developed. So if we take the development approach, you want to have different components for each of them. If we take the infrastructure approach, it's pretty much the same. You just want to have multiple machines for different use cases. So here, I just took my machine, and instead of having one, I have two. I have one for the web server, and in the backend, I can have one for the database. Pretty easy. You just spin up a Windows machine, get the backup files from the previous one, start a new one, and it's going to be a pure SQL server as you would have on premises. The only good thing, you can go from the first setup to the other one in about 5 minutes. So that's really the key of making sure that you can start simple and just scale as needed. But here, most of you are developers. You don't want to have to manage a SQL Server database, making sure that it is highly available, that you have the backups, that you have all the security that's embedded, and all the right configuration for your workload. What you want is just to have a database that works. So for this kind of use cases, we have, and we provide on AWS, what we call managed services. One of them is Amazon RDS, Relational Database Service. It's a service where basically you just start a SQL Server instance in a few clicks of a buttons. So you just ask for a machine that's going to have 4 vCPUs, that's going to have 100 gigs of disk. Press start, and 10 minutes later, you have a new database that is up and running, and you can start using. The good thing, failover is automated. It's just clicking that you want a highly available setup. It's going to be made highly available for you. And within 5 minutes, if a machine was to fail, it would start up again and be available somewhere else. So applications are really reliable just using that. And same, you have patching of the OS, patching of the database, you have backups that are automated. So most of the things that are pretty heavy in implementing yourself on a database are pretty much automated on AWS. So that's the first thing you want to have. You want to split the application in multiple tiers and make sure that you can scale them independently. Then what you want is to make sure that failure will happen. So what you do, you should plan for it. And that's really one of the key things you want to have in the cloud is planning for failure. And one of the design is you must design for failure. So if you design for failure, usually nothing fails. Because if a machine was to be unavailable, you would have another one that would just take the load and continue serving your users. So there's some tricky points to have in here, like session management. If you have session state in memory, you want to have something that will manage the state for you. So we'll get to that just a bit later. But except from the state management and some shared object configuration, most of the application and the web applications on IaaS, of course, can be made highly available just by spinning up new machines. So here you have a highly available setup. If one machine was to fail, the other one would go with the load without any problem. And if the database was to fail, it would automatically fail over to the slave that is a synchronous replica of the machine. So really simple setup. And you just have a load balancer in front. Again, load balancer. An AWS service, you just click or call an API, and the load balancer is going to be available for you. This setup works. You can go to a few hundreds of users without any problem. But one of the good things is you can even scale bigger. Using exactly the same principle, you can start having real replicas of your database. You can start having multiple machines. And you can scale this setup. And we have customers that scale this setup for multiple hundreds of thousands of users. So that's pretty good. But as you see, it looks big. It looks not efficient. So you want to have something that is a bit more efficient than just adding machines when you have more scale. Yet, this is a setup that works. So what to do now is you have something that works, you have something that scales, you have something that is highly available. So now we want to have something that is cost efficient. You want to have something that uses the right tool for the right job. And one of the trickiest things in applications now is not to have compute. With cloud, having compute is just being one machine, 10 machines, hundreds of machines. It's just the same API call. So what you want is to have the storage option for your data that you want and make sure that you use exactly what's needed. So AWS provides multiple ways of storing data, from the traditional RDS, which is SQL Server database, or PostgreSQL, MySQL, or Oracle provided as a service. But you can also have NoSQL databases. So if you've ever heard about NoSQL, we have a service that's called Amazon DynamoDB. It's a managed NoSQL database just for you. You can have search engines, so you can index documents and query them pretty fast. We have cache, and we also have Amazon S3, which is a file storage or an object store that is available as an API. So depending on the use case, you can have, and you will certainly have in your application, different ways of storing that. One of the use cases, I don't know if any of you has deployed a SharePoint application. SharePoint, by default, stores all the files in the database, which is fine because you have a SQL Server database. But now imagine I have lots of users, lots of files, pretty big files, like multiple gigabytes file. I'm going to start having a database that is going to be terabytes of size. If I could just take the file storage out of the database and store it, say, in an object store that is made for storing files and that has virtually no limits, I could have a SharePoint setup that would scale a bit more, and even much, much more. And we have partners that basically do that just for you. They take the data out of your database and just store them on Amazon S3 for having high available and really, really cheap SharePoint files. So it's the kind of setups you want to have in your application. So here, you can focus on efficiency. So I took the same application. I just changed a few things. Data that should be NoSQL, like things, if you take, and the example is an image site, comments on an image or on a blog post or on something are not something you want to have lots of queries, relational queries around. It's something that exists as an entity. And if you have something that is easily made as an entity, it's something you want to store in a NoSQL database. Same, I have, let's say, files that are stored and that are served by my application. I want to use Amazon S3. It's a file storage. It's highly available. It's made available on the internet if you want directly without having any server. So you can use multiple tools to make sure that your application will only focus on what provides business value for your users, and not just making sure that you have an IaaS setup that can serve files pretty fast. You won't add any value to your company just by tuning an IaaS server for sending files. You're going to add business value by providing new workflows, new features more regularly to your company. So once you have a setup like that, what you want is to measure, to automate, and to iterate. One of the key points of the cloud is that it gives you the ability to start new machines, stop new machines, change the instance type, change the setup really fast. So what you will want is first to measure everything. You will want to have logs, to have data points that are taken for each page of your application, for each batch process. How long did this image resize or document generation process take? This video process too. So you want to have metrics, and we have a service that's called Amazon CloudWatch that gives you the ability to concentrate these metrics and have a single pane of glass vision of all the metrics of your application. Whether these are system metrics, CPU, RAM, network, disk usage, or if these are custom metrics, like the number of pages viewed by your customers, number of users you have at a specific point in time on your platform, you can have really fine-grained metrics. And the good thing with that, you can have alerts. And once you have alerts, you can automate stuff. So having an alert when an application uses more than 50% CPU on one server gives you the ability to say, okay, I have a platform that tells me that I'm overloaded in CPU. Since my cloud is fully configurable and fully programmable, I could have the cloud directly answer that by adding few other machines and just spread the load on more machines. It's a service that's called auto-scaling. That's on your right. And it's a service that basically takes all the alerts and can act based on them to make sure that your application will be highly available and scalable as needed. If one machine was to fail, the auto-scaling group would automatically create a new one to replace the other one. So using that, you have high availability and performance, because if you have more users that you can take, it's going to create new machines. And we have a large set of services that are from Elastic Beanstalk, which is a complete platform as a service kind of application. You just put a zip file with your code, it's going to be deployed, and everything's going to be managed for you. To more do-it-yourself EC2 kind of side, where you start the machines, you configure them, and you automate them. But everything is available, and you can start using really easily. So what it gives is, on the same application you had, you can add what we call auto-scaling layers. These layers are going to be where new machines are going to be created automatically, are going to be destroyed where not needed, and are going to be replaced if one was to fail. This is really one of the keys of having a high available architecture. To finish up, what you want is you want to have an application that focuses on different steps. So if we take again the single responsibility principle, let's say you have an application that accepts file in input, document, and generates PDFs on the output. You could have, so you're going to have a website that accepts the document in input, and you're going to have a process that takes them and just generates PDFs or generates images out of them and sends them back to the end user once it's done. You could do that in just a single application. The bad thing is the more user you have, the more work you're going to have in batch. So that's not going to provide any value to your user. It's just going to use CPU and RAM from each of your machine. So what you want is you want to have, again, the single responsibility principle, and you want to split your application in multiple tiers. And that's what we'll see in the demo. So what you want is basically a message queuing system. So you want to have an application on the front end that serves the customer, takes the order of the customer, like resize this image. Okay, I have it. Thank you, customer. I'm going to process it so the customer can continue doing what he does. And in the back end, you will have a process that will resize the image. So in this case, you can use Amazon Simple Queue Service, SQS, but we have many other different services for sending emails if you want, for having workflows with states and with multiple steps. So depending on the use case and your application, you can have a really nicely decoupled architecture. So if we take the same application, so remember we started with just one machine. This application is pretty much what Netflix does, kind of like. So you could have applications that basically serve 30% of the bandwidth of the United States in peak. So it's applications that can scale quite a bit. And basically you have here an application that is completely decoupled and on which you can scale any layer. So if, for instance, you have a website that is overloaded, but you don't have many backend processes running, you can basically shut off all your backend machines and just put everything on the website. On the other side, if you have many backend processes that are coming up and the website doesn't move, you can add new machines for the backend without impacting the rest of your application. One of the good things is that it's going to give you a pretty high available and mostly a cost-effective architecture. You can scale exactly what you need to scale when you need it. You don't have just to add new machines and have a bigger infrastructure whenever something happens. So, this slide is hidden. I wanted to show you an example, which is exactly what I'm going to show you. So it's a simple application. If you come to the booth, we can give you the source code. It's just the demo stuff. It's fully built on ASP.NET, hosted on IIS. So it's really nothing fancy about it. It's a website that's made for posting images and resizing them. So really a simple use case. Don't know if any of you has used 9gag. It's one of the platforms that's hosted on AWS. It's made for sharing images over the internet. So we have a website. When an image is posted by a user, it's stored on Amazon S3. And then we have another process that's made for resizing the image. And in the backend, we have some databases. One for SQL Server that is going to serve the users and the content and just the information about the users. The other one is going to be DynamoDB, which is a NoSQL database that basically stores anything that is related to posts and comments. So, up as usual, PowerPoint messes up my screen. Up. So, we're back. So if I go to Visual Studio, the first thing you can see is that I created a database on Amazon RDS. And this database is exactly a SQL Server database. I access it using the same usual tools that I would do for any database that would be hosted on my computer or anywhere in my data center. It's exactly the same database. So I just connect to it, use the SQL Server Object Explorer, and I can just basically run queries against it. So here I'm just asking for the list of users that are in my application. So really simple. It takes about 15 minutes to create a new database. So something you can pretty much do. Then I'm opening the AWS Explorer. It's a plugin for Visual Studio, so I don't have to leave Visual Studio. I'm still in Visual Studio, and I can start managing all my AWS resources. So whether it's a dev environment, I don't recommend you to use that for prod, because you're in dev, you don't want to mess up prod. But I mean, it's the kind of thing that you can automate and you can start managing your environment. So here, let's say I have two tables, so comments and posts, that basically stores the data for the information that is published on my blog. So I can just double-click on the information, and I see the entries, as I would do for any entry in a SQL Server database or the likes. So it's really easy to manage, and you can start writing queries, you can start sorting stuff or modifying stuff directly from here. If I was to create a new table on DynamoDB, just to show you, because you don't have the concept of a database in a NoSQL world, you just create tables and tables or entities, depending on the word you want. I can just create a table and call it, let's say, tests with an ID. I press create, and here I already have a table that is available for coding. So it's really simple, really fast to create a new entity and start using it in your code. If I go to the code that I'm writing, I have multiple different services. So here, for my database, for the user seats, it's a SQL Server database. I can just use a DBML file, so it's a link to SQL entity, really the small ones, that just basically takes the data from my database and maps it to a C# file. So if Visual Studio is OK with opening the file, yeah, you can see it's exactly the same thing you would do for any SQL Server database. And if I go to my service implementation, here I can see that querying the database can be done directly with link to SQL, so directly from C#. So it's exactly what you would do for a SQL Server database. If I were to query now, let's say DynamoDB, what I'd want is to have a familiar way of querying DynamoDB. So I could create an entity on DynamoDB, and as you can see, it's just a small class in .NET with some properties, and you have the familiar, once again, annotation kind of things. You just put an annotation that say, it's going to be the DynamoDB table that's named posts. And just by putting that, DynamoDB knows, and the SDK for .NET knows exactly how to map the information directly to DynamoDB. So I can just say, I have a hash key. So the hash key is pretty much like the primary key you would have in NoSQL. And this hash key gives me access to like the ID. So with just that, I can query directly DynamoDB from my code. And if you look at the implementation of the post service up here, querying is made through a few simple queries in .NET, which is load. I just put the type. It's a generic. I just put the type, and I get the object that is deserialized for me. So really simple, really easy way to have an application that uses a NoSQL database. So this application is here. As you can see, it's a really simple application, just a post. And if I want to create a new post, I can simply put a comment, just select an image. I'm going to be really creative. I have it. And I can send the post. So thank you, you've posted a post. If I go to the home page, you can see here I don't have an image right now. The reason why I don't have an image is because I coded the application in a loosely coupled way. So the process of taking the image from the customer and the process of resizing them is completely separate. And what the application did when I just posted a new image, basically just posted a message to Amazon SQS. I have a queue, which is called image resize. And here, I have a new message that says, please resize this image. And that's about what it does. So I have another batch process. So for this example, it's just a simple exe file. And if I just debug the application and start a new instance, what it's going to do, it's going to ask SQS to get data out of, so to get just an order. Once it gets its order, it just resizes the file, and it's done. And then it starts pulling again SQS for new messages. So really simple. I'm going to show you the code for just asking SQS. And here, since I have resized my image, now I can display it. And so I have just a thumbnail and a base image. And so it's just images that are limited in size, so it's no more than 500 pixels in width. And here I can add new comments with like nice image. And even if it's a NoSQL database, I can still have like relationships. The only difference is I'm not going to have a primary key and a secondary key and a foreign key for linking stuff like I would have in a database. It's just going to be the applications that manage this relationship. So which is better in terms of design because you can scale each and every one of your tables independently from one another. So let's say I have millions and millions of comments on a few thousand of images. I can have a really large comment table that's not going to have any impact on the image table. So I can really scale as needed. So reading data from DynamoDB is from SQS. You'll see my resizing program is just a single class. And so if I go just to the main, querying data from DynamoDB is just having a new SQS client and calling a receive message. That's about what it takes. I just call it receive messages, and here I have a full queue that is fully managed for me. The good thing about the managed services from AWS is it can scale from one message per hour, which is pretty much the case I have here, to tens of thousands of messages per minute without any problem. You don't have to manage anything, you only pay for what you use. So it's a pay per message process. So as I said, here I've just decoupled my application. It's a pretty simple application. What I'm gonna want now is to make sure that this application is managed. So I want to have metrics on what's happening on my application. So here the application is running on my machine, so obviously I cannot see the level of CPU it's using because it's my desktop. But what I can do pretty easily is, and it's what I've done in the application, I've just added a few metrics to my application that say what are the number of pages and pages per second that have been served by my application. And this is stored on a service that is called Amazon CloudWatch. And it gives you real-time graphs, so it's minute-per-minute graph of everything that is going in my application. So as you can see, I don't have many users, because I'm kind of lonely. But here, I've been creating an image and displaying pages. So here you can see we've had 3 pages that were displayed. So the page per second is really low, but I have 3 pages that have been displayed in this specific minute because I've just been demoing the creation of a new image. So if you want to see this kind of application and have example code, just come to the booth, we have the code, and we can give it directly to you. So if we get back to here, just to wrap up, what you want to have is you want to focus on the 4 pillars of a cloud architecture. You want to have an application that is secure, that is performant, that is highly available, and that is cost optimized. Cost optimization is something we don't often think about. I'm a dev, and I've been a dev for quite a while. It's not something we kind of embed in our designs when we start an application. Thinking in a cloud world is something where basically you can say, okay, I'm going to design that, but by the way, it's going to be cheap. Or, okay, you want this feature? By the way, that is pretty much expensive. So you want to maybe take care of the way you implement it, or even challenge the business and say, you sure you want to do that? That's going to cost a lot. So you can have really a nice way to challenge the business and challenge the design of the application. And then you're in an agile world, and here we've had many talks about behavior-driven development and stuff like that, TDD. So you want to have something that is agile, where you can try, you can adapt, you can optimize. And the cloud is really a good test bed for that. When you start using a cloud platform and you basically mess up because you have a machine that is undersized, it takes minutes to have a bigger machine. And on the other side, if you have a machine that is just using 3% of CPU, you're not stuck with it for the next 5 years. You can just scale it down and have a machine that will just cost less. And maybe with this money, you're going to have another project because your IT budget is not something that scales as much as a cloud infrastructure. So you also want to capitalize on your expertise. Using AWS, you have the familiar development tools. If you're used to Visual Studio, TFS, and using Link and everything, you can just keep on using that. You can push your applications to the cloud without any change to start up with, then start optimizing it bit by bit once it's in the cloud. And latest, you want to monitor everything. Really, if there's one key point you want to have metrics about each and everything that is happening in your application. And not just only averages. You want to know what's going on if one specific user in your site has a bad experience, you'd like to know why he has a bad experience. So really, wherever you can, please add metrics, add logs, and make sure you can consolidate and aggregate and analyze each and every one of these data. The goal of it is basically you're going to have to sleep at night. I don't know if you've implemented a DevOps strategy in your company. Just as dev, remember that when you're in a DevOps company, you can be paged at 2 a.m., which usually don't happen. So you want to have an application that basically takes into account the fact that you can be paged at 2 a.m. and you want to have an application that basically manages itself so you don't have to wake up at 2 a.m. And having the right level of monitoring and the right level of automation is something that will just help you sleep. Believe me, you'll love it. So thanks, that's about it. I'm just right on time. You've got my email address. We have a booth here, so just, don't hesitate to come. We have some sites and everything is available online. By the way, for those who don't know, we have $100 credit vouchers. So for the first one who come with us to the booth just after the talk, we have credits so we can give you $100 of credits. Thanks a lot and have a nice day.